Terrains can be created in a variety of different ways. But the most powerful way is using the function editor, whether it's for height field terrain or procedural terrain. One way is to start with a procedural terrain and then convert it to a height field terrain after you've generated it. So we're going to take a look at editing functions and the altitude production for procedural terrain. And there's a lot of different ways to generate terrains with different nodes. So I've just added in a procedural terrain. I've got the terrain editor open. Now, one thing you might notice on the left is we have an option checked right here or activated, and that is the 0 edges option. What that does is it multiplies the outer edges by 0, and using sort of a Gaussian sort of circle there. And that gives us a mountainous look. But I want to see the full procedural, so I'm going to go ahead and turn off 0 edges, and now we can right-click and edit the function. Now, first off, if you want to match your interface to match mine, because I am using a different setup than the default for the function editor, if you right-click on the top here where it says function graph, there's a few options here. Toolbar, which is that top toolbar, and the node toolbar, which is on the left, which I find way more useful than using the node types, which is this option here where it gives a list of all the different nodes. So those are the options I have set up there. We could also choose to unlock or lock the workspace so that way we could customize that a little bit more. If you take a look, and I just want to get those options on top showing back up, we have the node preview, which is the output observer, and then the function node preview next to it, which is going to give us numeric output for the X, Y, and Z, so we can take a look at the profile of the terrain. If we want to see the actual size, I'm just going to scroll down here, set the scale to 1, because it'll also show us beyond the current scale if you want to zoom in and out, since the procedural terrain is infinite. Another thing I want to do is just increase the resolution a little bit to 512 by 512. Of course, since it is a procedural, it will continue to subdivide as we render, and it'll look much better. But this will give us a slightly better preview than 256 by 256. But as we're designing, I want a faster update. So if we take a look, if you're not familiar with the function editor at all, on the left we have the input nodes, and on the right we have the output nodes. So right now what we have is the position vector, and that connects to the fractal, and then from that fractal we get a numeric output, which is the height, which connects to the altitude output. We also have a couple of nodes on the vector, one being the multiply, which is going to change the scale of the vector to change the overall scaling of the fractal to fit better with the object parametric mode. So if I was to change this to, say, 32, it's going to scale up the terrain a lot more. So the default's 128 if we're working with object parametric. If you're working with the world mapping or object mapping, you shouldn't really need, or it shouldn't even create that multiply. Now the one before that is the vector 3 seed. Now this can be modified by hitting the randomize button, which is right next to the altitude production. We click that, and what it does is it changes the vector to change the origin of where the fractal is being generated. And this is really useful for once you've established a style for the terrain, you can keep randomizing it until you get a variation that you like and something you can move on and move forward with. That works with materials and clouds and stuff as well. So right now we have just a very basic fractal as just using a Perlin noise. So what we can see is we have the simple fractal selected, Those can also be created. Over here on the left, we have noise and fractal. These are input and output nodes. Color, texture map, filter, constant nodes. We have turbulence, and then combiners, dynamics, layout, and then math, and the last one is for loading in metanodes, which we'll probably take a look at later, which is essentially just grouping nodes together. And then you can create a metanode out of those, which is essentially taking all of these and condensing them into one. And then you can also just click on the metanode, edit, and that way we have it contained within one node. So it's really good for organization, also creating special tools. I'm going to go ahead and just ungroup that. So right now we're using like I was saying before, the simple fractal. There are some terrain-specific ones, which are the terrain fractal version 2, and the different Rocky Mountain fractals that are available. Keeping it on the simple fractal, we can go to the noise and take a look at all of the different noise patterns that are available. If we go to cellular patterns of Voronoi, and the Voronoi gives us a really cool terrain, and what we can do is increase the largest feature scale, and we can see that in the nice little preview here. And then if we switch over to the terrain editor, then we can start to see the overall scale, so we can use that, mix that with other things, but that's always a really cool node. There's lots of options within it. Going to the top, we can click edit, and we can choose the neighbor mode, which is sort of the grouping of these cells, and end up with some really interesting looking surfaces. And then we can also change the profile. There's the flat mode, which is typically only used for materials because it is just too much for terrains. The spikes, which looks better reversed by using closest neighbor, rounded and smooth rounded, and just different profiles for that option. So the Voronoi is really useful. It's pretty cool. We can also rotate it on the vector internally and make it a little more randomized. So you can go through and take a look and see what these different options do. I'm not going to go through every single one because that would just take too long and it would be unnecessary. So if we take a look at further at these options, and pretty much all of the fractals are going to have similar features here, with a metascale, largest feature, smallest feature, roughness, and gain. These are pretty typical throughout, along with the wavelength and origin. So the wavelength is going to be the scale per axis. So if we set that x on 9, it's going to stretch us out on the x-axis. I'm going to bring that back to 4.5. The largest feature option is going to take and essentially scale these blobs that we're seeing to what right now would be sort of meters, or using the view internal unit. One thing you'll notice is, let's say we set this to 20, then we're probably going to see scales about twice that for the largest feature, because that option of 20 is not only going to include the positive values, but also the negative values of the function, or the fractal. And since everything is essentially between -1 and 1, which is the altitude output, -1 being black in the lowest part and 1 being the highest, it will of course go higher than that or lower than that. But typical range is -1 to 1. And it does take into account the negative values with that largest feature. Now the metascale takes that largest feature and groups that largest feature together. So it sets a scale, and I'm going to have to go in and change the vertical gain because that is just way too high up. So we can adjust the vertical gain to adjust the height of the terrain. So once again, the metascale groups the largest feature together into another scale. So meta, of course, being a larger than and a bigger scale. The smallest feature option allows us to define how small or how large our fine details are. So I just increased the smallest feature amount to 4. And you can see how much it has smoothed out the terrain. This is really useful for animation when you don't need really fine details. So you can use that to remove anything you really don't need. It can also improve just render quality depending on how the terrain is set up. It's variable. So it is a useful option that's available. You might not always need it, but it is there. And it works as an easy smoothing for these fractals. But that's, of course, going to be built into the fractal itself. You can't go beyond that. If you have a couple of different fractals together being combined, after that fact, you can't go in and add a filter to smooth it out like that. Unless you're using a height field terrain, which we're not right now. So let's move on. We've got roughness, which is going to make the terrain, of course, have lots and lots of detail the higher we go. And as we move it down, we start to see more of kind of what we had before with the blurred look, but now we're getting the actual shape of the Voronoi, losing our roughness features. So if we increase the smallest feature amount, we're really not going to see any change because we've essentially removed all those details by removing the roughness. We could even remove the roughness or increase the roughness all the way and then use that smallest feature option to smooth it out if that's what you're looking for. So I'm going to set this to the default, which is 0.5, and bring the smallest feature back down to 0. Gain is going to essentially multiply the output, and now we can see it's going to be really high up. I have auto fit turned on here for the output observer, so we don't really see that in the output observer and that overall gain there. And you can see when I turn that off, it's set to 1. You can see why that scale before was so high and I had to reduce that vertical gain. So I'm going to turn auto fit back on. We can see our terrain. And moving on, within the simple fractals, we also have a filtering profile that's available to modify the internal shape. When we click on this filter, I just edited, right-click, edit filter. Make sure we bring that out in front. So we have -1 to 1. And what we can do is double-click to add a point. And we can see how that's affecting the profile. We can move that over here, and now we're going to get like a sharp spike towards the top and smoothing for those lower areas. We could raise that up and cut it off further. And I'm going to go ahead and increase the size of that so we can see it a little better. We can also turn on the curves if we want it to be a smooth cutoff. We could also vary it. And this is all internal and not part of a... We could also add filters like this into the altitude output, but this one is built into the fractal itself, so we get a little more control of how we want to blend it in. The creep in amount, the max amount that this covers. So there's a lot of different ways to modify and edit these fractals to get all different kinds of terrains. And of course, these can also be applied to material functions as well. It's not just limited to terrains. Anywhere you find the function editor, most of this stuff can be applied. And pretty much simple fractals are available just about any part of the function editor or any function in the program. So let's take a look at one of the more terrain specific nodes. I'm going to go ahead and delete that simple fractal, and you're going to see we get nothing in our terrain editor or the output observer. And I'm going to right click, add in a fractal, and I'm going to choose the terrain fractal version 2. Now this automatically connected to one of the vectors, but it connected to the randomness vector 3 seed rather than the multiply by. So what we can do is just take this dot here, the input, and connect that to the output of the multiply by. And then we can take our altitude and connect that to the altitude output. Now once we drag it onto this terrain, we're going to see a couple of different options. We have altitude, rough areas, and very rough areas. We're going to stick with the altitude right now. The rough areas are typically used for controlling material distributions, defining where material shows up, and controlling the alpha of different material layers, which we'll take a look at a little later. So now we can see that terrain fractal version 2, where we have essentially the same options that we had before, along with some additional features more specific to this fractal. And we also see that we don't have that filter in the profile as we did with the simple fractal. So the base settings, wavelength, that's what we had for the simple fractal as well. I'm going to go ahead and increase this to 4.5 all the way across so we can see a little bit larger without having to go in and change the largest feature in metascale. Defaults are typically 40 and 10. For metascale, largest feature looks pretty good usually. We have a base roughness, so we can make it really rough if we want, or we can make it a little smoother. So this is used as a mix of internal fractals to generate this. We have turbulence options, which will twist and distort the terrain. Let's go ahead and bring that down to 5 and 20. For the metascale and largest feature, we can see a little bit more. We could also go up to the multiply by. We could set that to 256 if we want to increase that, or we can bring it down. And there's a lot of different ways to just modify the scale. I'll bring it back to 128. Buoyancy, large scale contrast, lots of different options to play around with, get some cool looking terrains. There's also the terrain fractal version 1, or the original terrain fractal that's been around since, I believe View 7. So that one's a little bit older, but it's still useful. It doesn't necessarily replace the old fractals and make them obsolete, because it's designed differently and it gives you a different look. So they are still definitely useful. We do have different options for that. But most of them are relatively the same, but we can change the internal noise. So let's say billows, we can do a bump surge, we could distort it more. Let's see those different turbulent options showing up. And then there's also the Rocky Mountains, which are really cool. And for that, I'm going to, let's bring down the multiply by, well, let's do 8. And this is going to give us more of a mountain look. These can take a while to render depending on how many iterations you set it up for. So if you take a look under the overall aspect, we have an amount of iterations, and we can go up to 9. So it'll keep adding additional detail, but it will increase the render speed. If you're getting tearing with that, then you can increase the subdivision quality. And then we have some built-in distortion and a stretch factor. And then there's also the eroded Rocky Mountain, which has similar features. So those are their terrain-specific nodes for quick terrain generation. I want to go back, and we're going to take a look at customizing these nodes a little more so that we're not just depending on a preset. So I'm going to go to Fractal, and this time I'm going to add in a variable roughness fractal, which is very similar to the simple fractal, except it has a variable roughness option, which is a smoothing level. Connect that to the altitude output. Now we can see just a basic gradient. We could also go into here, Perlin noises, and use the terrain Perlin noise, which is the internal noise used for the terrain fractal. Okay, I'm going to go ahead and decrease the gain. And one thing we can do that's really cool, and this is available for just about anything that has an origin, and if you're deconstructing any presets or anything, you'll see this used throughout many areas of the program and different available content, is the ability to use a turbulence to adjust the origin. Now the origin is the position of the terrain, or the position of the fractal, along different axes. So we can move it along on the X. You can nudge it just a little bit, and it really depends on how far you want to go. So that adjusts the origin on the X and the Y. We could also go through on the Z and change that. But what we can also do is if we go ahead and click on the origin, we can select Connect Parameter. And this is going to give us the ability to control the origin with another node. So if we select this constant that was just created, which is going to be 0, 0, 0, which is what it was currently set at, we can replace it with a turbulence node. And if you want scales to match, we're going to connect that to the multiply by as well. So we can set a largest feature and an amplitude amount. Now this is just a simple turbulence. We're not really seeing too much out of it. Increase the amplitude to 50, and now we can see all those little distortions showing up. Now this is just a simple turbulence. It's just a built-in. I believe it's just sort of a Perlin noise. But we can also go to miscellaneous style, which will give us a noise to choose from, where we can pick what shape we want it to be. Or we can use the advanced turbulence, which has vortices, which are tiny little extra bits of detail, and we could use a 3D noise, which really isn't needed for the terrain editor because everything essentially is outputted as 2D. So if we pick something that is a little more obvious, let's do flat patterns, or actually distributed round samples. Increase the largest feature amount and the amplitude. And the advanced turbulence is going to be a lot more powerful with the sliders, or at least apply itself way more. Okay, so we'll remove the amplitude, and now we can start to bring it in depending on the scale. I'm going to go ahead and edit the distributed pattern, set it to 0 to 1 sample per cell, and we'll do smooth round, and I just want to see if we can pull out that shape on there so that we can see the little dot showing. So what it's using right now is circles, which is the round samples, rounded circles, and distorting based on that. So we can choose different shapes, and that's kind of cool looking. I do like that. And this shows a good use of the vortices. If we turn off vortices, we really lose a lot of that turbulence we have built into there. So I do like to keep that option on, or I want to, at least in this case. So there's lots of different types of turbulence you can use, and this is still a fairly basic setup. We really only have 2 nodes, and we're getting a cool looking terrain out of it. And then we can increase the resolution as needed. I'm going to go ahead and just stick with this right now and render it. And here's a render just using the final render quality. And I really like the way this detail is showing up here. One thing I notice is it almost looks like there's a little bit of tearing, like there's not enough geometry here. And that's when the quality boost option becomes really useful. So if we need to, now we can increase the quality boost, which will add to the subdivision amount. And it looks like we're having trouble around these lines right here. And of course, because it's procedural terrain, increasing the resolution is not going to change anything, just the preview or the material layer. So if we want to, we can force the render quality a little higher. Another thing I want to note is that the scene has an overall render quality, which will affect quality boosts throughout the program. And this option is available under the render options, and you will see it as the advanced effects quality. And if you take a look at the presets, you can see we start to get into higher advanced effects qualities as we move up the render quality. Final and broadcast 46, superior 59. 59 is usually the best way to go. You can go in and set user settings if you want and customize it. Change that advanced effects quality. And what that does is it multiplies all of the other quality boosts throughout the program, and there are quite a few of them. Essentially, we have one if we go to the atmosphere editor, F4 on the keyboard. Under lighting, we have a quality boost, and that is for radiosity, basically anything other than standard. Global ambience, ambient occlusion, global illumination, global radiosity, and you can increase the quality of that by increasing the quality boost. If you increase the advanced effects quality within the render options, it will increase the quality automatically. So keep that in mind when you're using quality boosts with lower render settings, because if you do want to jump that up later to a higher quality render, it's going to make these quality boost settings possibly be too far beyond where they really need to go, and you're going to end up with renders that take unnecessarily long times. So there's a few other quality boosts in the program, but essentially one thing to keep in mind is that they are modified by the advanced effects quality. Looking at the OpenGL right now, I think it's a good example of how the geometry divides itself. It does divide itself in squares. And if we take a look at the OpenGL preview, we see this tearing between this higher resolution and lower resolution in the back. Sometimes, depending on the scale of the scene, how far you are away, sometimes you will notice tears when you're rendering a higher quality render, and not just the OpenGL. You'll see a little bit of tearing in there sometimes in between those resolution changes. And if we go into the top view, we can see the different resolution changes. We have a high resolution here, slightly, and then it goes a little bit less, and then even lesser than that. So if you are noticing tearing around those subdivision separations, you can increase the quality boost of the terrain for procedural terrain, and then it'll increase that resolution and kind of get rid of those tears within the terrain, which don't always show up, but they can.